In this video, we are going to look at the rule of addition of probability. Let's say we carry out a trial where we flip a coin. Upon flipping a coin, there are only two possibilities that we get. We either get head or we either get tail. Head and tail are such events that don't occur at once. That is, if you flip a coin, you either get head or you get tail. It is not possible to get both head and tail at the same time. And such events are what we call mutually exclusive event. We call them mutually exclusive events. Again, mutually exclusive events are such events that don't occur at the same time. Let me show you with the help of a Venn diagram. Let's say this right here is the Venn diagram of the trial that we just carried out. This right here is all the heads that we get, and this right here is all the tails that we get upon carrying out the trial. And as you can see in the Venn diagram, the two sets, that is the set of heads and the set of tails, they don't overlap with one another. That is, there is never a situation when head and tail occur at the same time. In this particular condition, if you have to find the probability of getting head or tail, you simply add the two probabilities, probability of getting head plus probability of getting tail. The reason being, in this case, the probability of getting head and tail, that is getting head and tail, is 0. So, mutually exclusive events, they are such events that never occur at the same time. And since they never occur at the same time, the probability of getting those two events at the same time is obviously 0. And the probability of the occurrence of two events can be calculated by simply adding the probability of each event. Let me give you another example. Let's say I have a dice right here. Okay, let me draw a better dice. Okay, so I have a dice right. Shit, it's a messed up dice. Okay, I have a dice right here. So I carry out a trial. The trial is rolling a dice. Once I roll the dice, there are 6 different possibilities. I either get 1 or 2 or 3 or 4 or 5 or 6. There is never such an event, or there is never such an occurrence where 1 and 2 occur at the same time. 1 and 2 and 3 occur at the same time. When you roll a dice, you get only one outcome, that is either 1 or 2 or 3 or 4 or 5 or 6. The rest of the numbers, they do not occur. And these events are what we call mutually exclusive events. So in this case, the probability of getting 1 or 2 is simply equals to probability of getting 1 plus probability of getting 2. Because the probability of getting 1 and 2 at the same time is 0. Again, the probability of getting 3 or 4 or 5 is equals to probability of getting 3 plus probability of getting 4 plus probability of getting 5. Because you are never gonna get 3 and 4 and 5 at the same time. Let me make the concept clearer with the help of an even better example. Let's say I have a bucket right here, and this bucket contains 4 red triangles, 4 red squares, 3 blue triangles, and 5 blue squares. So the first question is, what is the probability of getting a red triangle? The probability of getting a red triangle. So for that, you have your simple formula, that is desired outcome divided by all possible outcome. So what is the total number of possible outcomes in this particular example? 4 this right here, this right here, this right here, and this right here. Add all of them together. 4 plus 4 plus 3 plus 5. So these are all possible, all possible outcomes. What you need are your desired outcomes. What are your desired outcomes? Your desired outcome is to get a triangle, a red triangle, not just any triangle, a red triangle. And there are altogether 4 red triangles. So that's your desired outcome. Desired outcome. So the probability comes out to be 4 divided by 16. Second question. What is the probability of getting a triangle? Simply a triangle. So there are a total of 16 total possibilities, out of which you have a total of 4 plus 3, 7 triangles. So the probability is 7 by 16. Third question. What is the probability of getting red? So a total of 16 possibilities or 16 possible outcomes, and desired outcome is getting red. And there are a total of 4 plus 4, 8 red. So the answer is 8 by 16. Now here's your tricky question. That is, what is the probability of getting, a red or a square? Let me show you with the help of a Venn diagram. So this is the Venn diagram. See, you have the possibilities of getting red. Wait. You have your possibilities of getting red. So that's your red. And there are altogether 4 plus 4, 8 possibilities of getting red. Then you also have your possibilities of getting a square. Possibilities of getting square. There are altogether 5 plus 4, 9 squares that you can get. 9 squares. But the thing is, when you pick stuff at random from this bucket right here, you have a possibility of getting red because there are red stuff, square because there are square stuff, and also there's your square as well as red stuff, which is the common between the two. There are altogether 4 squares that are also red. So in this trial, you can have events such as getting red, getting square, or even getting a red square. That is two different events occurring at the same time. And this is what we call not mutually exclusive events. In mutually exclusive events, you had events that never occurred at the same time. Here, since you have two different events occurring at the same time, they are not mutually exclusive. Okay, so that's one concept. But the thing is, you need to find the probability of getting either a red stuff or a square stuff from this bucket when you pick something out of it. So that is going to be equal to probability of getting red stuff, right? Probability of getting red plus probability of getting square. But now here's the thing. There is also a probability that you might get a red square. And this red square is a part of red as well as a part of square. I mean, this red square is added in red as well as added in square. So to get the correct probability, you have to remove this part from the equation at least once. So you have to remove the probability of getting red and a square. Again, so what is the probability of getting red or a square? So the probability of getting red is 8 out of total, which is 16. The probability of getting square is 9 out of total, which is 16. But then there's also the probability of getting red square, which has been added twice in red as well in square as well. So you need to remove it once. So probability of getting red square 4 by 16. Again, what is this? This is the probability of getting red. This is the probability of getting square. And this is the probability of getting red and a square. In mutually exclusive events, that is events where two can't occur together, the probability of getting red and a square would be 0. So the probability of getting red or a square would simply be equals to probability of getting red plus probability of getting a square. Okay, last example. Let me give you last example. Let's say what I have here is a deck of cards which has a total of 52 cards. Now the question is, what is the probability of getting a king or heart? So if I close my eyes and pick a card, there is a probability of getting other cards. There is a probability of getting king. There is a probability of getting heart. But then there is also a probability of getting king of heart. That means two events occurring together. So this is also not mutually exclusive. It's not mutually exclusive. And you know the formula for not mutually exclusive. So the probability of getting king or heart is equals to probability of getting king plus probability of getting heart minus the probability of getting king and heart. Again, let me show you with the help of a Venn diagram. Let's got all of this. So let me show you the same question in a Venn diagram. So here's the Venn diagram for the question. So there is a probability that you might get a king. There is a probability that you might get a heart. There are altogether 4 kings and altogether 13 hearts in a deck of 52 cards. However, there is also a probability that you might get king of hearts. There's 1 king of heart in a deck of cards. So the probability of getting a king or a heart is going to be equals to, what's the probability of getting king? 4 by 52. Plus, what's the probability of getting heart? 13 by 52. But then also there's also the probability of getting both king and heart at the same time, which is added here as well, which is a part of that as well and this as well. So you need to remove it once. So 1 by 52, which is equals to probability of getting king plus probability of getting heart minus probability of getting king as well as heart. And if it was mutually exclusive, let's say if it was mutually exclusive, this part would be equals to 0. So that's it for rule of addition of probability. Here's the revision. Rule of addition. Okay, here's the revision. You have rule of addition of probability. Under this topic, there are 2 possible situations. One situation is where the events are mutually exclusive. Mutually exclusive. That is, the 2 events, they don't occur at the same time. If this is event A and this is event B, event A and event B, they don't overlap with one another. And there is not mutually exclusive events where you have events that can occur at the same time. So let's say this is event A and this is event B. There is a possibility that event A and B can occur at the same time. The probability of getting event A or event B in case of mutually exclusive events is equals to probability of getting A plus probability of getting B. The probability of getting A or B in case of not mutually exclusive is the probability of getting A plus probability of getting B minus the probability of getting both A and B. In this video, we are going to look at the law of multiplication of probability. Let's say you carry out two different trials. First, you roll a dice. Upon rolling a dice, get a 6, and this is event 1. Second, you flip a coin. Upon flipping the coin, you get heads. This is event 2. The occurrence of event 2 does not affect the occurrence of event 1. That is, the occurrence of event 1 does not increase or decrease the probability of event 2. That is, upon rolling the dice, if you get a 6, this does not increase or decrease the probability of getting head. It does not increase or decrease the probability of getting tails. Basically, these two events are independent of one another, and that is exactly why we call these two events independent events. So independent events are such events that do not affect the probability of occurrence of another event. That is, when you roll a dice on one side and flip a coin on other, the outcome of rolling the dice does not affect the outcome of flipping the coin. That is why these two events are independent of one another. And in this case, if you want to find the probability of event A occurring as well as event B occurring, then you have to multiply the probability of individual event, that is probability of occurrence of A times probability of occurrence of B, and this is what you call law of multiplication of probability for independent events. For example, let's say upon rolling a dice, you get a 6, and upon flipping a coin, you get heads. So, what is the probability of getting 6 in dice and head while flipping a coin? It is equal to probability of getting 6 in dice times the probability of getting head after flipping a coin. The probability of getting a 6 is 1 by 6, your general formula for finding probability, and heads it's always 50%, 1 by 2. This will give you 1 by 12. So this is the probability of getting 6 after rolling a dice and heads after flipping a coin at the same time. So we have a question right here. If we randomly pick a card from this deck right here, what is the probability of picking ace twice in a row without replacement? So you have a deck of cards and you are going to pick two cards in a row. The question is, what is the probability that those two cards you picked in a row, both of them turn out to be ace? And the cards you pick are not to be replaced. That is, once you pick the card is removed from the deck. The card is not again added to the deck. Now, as per what I have taught you, this is how you need to deal with this question. So basically, the probability of getting ace card first and ace card second is equals to probability of getting first ace card into probability of getting second ace card. Probability of getting ace card is equals to, there are altogether 52 cards in a deck and there are altogether 4 ace cards in a row. So the probability of picking an ace card is equals to 4 by 52. The same is for the second as well, 4 by 52, and this is the answer. But, this is completely wrong. This is wrong. Because this question does not deal with an independent event. This is what I mean. See, let's separate the question into events. In event 1, so you had your first pick. In first pick, the probability of getting first ace card equals to, so there's a total of 52 cards in the deck and there are altogether 4 ace cards. So the probability of picking ace in first pick is equals to 4 by 52. Now let's look at event 2. That is right after picking the first card, you pick the second card. So second pick. The probability of picking ace card is not equals to 4 by 52. The reason being, see, once you have picked ace in your first pick, the total number of cards in the deck now has decreased. There were 52 cards, now there are only 51 cards because one card has been removed. And since that one card that you removed is an ace card, now the number of ace cards remaining in the deck is also decreased. There were 4 ace cards before, now there are only 3 ace cards. So in this particular case, the outcome of event 2, the occurrence of event 2 is affected by the occurrence of event 1. And such events are called dependent events. So what are dependent events? Dependent events are the events that are affected by the outcome of one another. Dependent events are such events where the outcome or the occurrence of one event affects the occurrence of another event. Like in this scenario as well, the occurrence of ace card in the first pick affected the occurrence of ace card in the second pick. The probability of second pick was changed from the first pick. Now you apply the formula. That is the probability of getting first ace card in first pick and second ace card in second pick equals to 4 by 52, which is this one right here, times 3 by 51, which is this one right here. And from this the formula comes out to be the probability of event 1 for first ace card times probability of event 2 after event 1. Okay, one last revision for the whole thing. All right, so here's the thing. So we are learning the rule of multiplication of probability. Under rule of multiplication of probability, there are two different types of events that you know about, that you need to know about. The first are your independent events, where the occurrence of one event does not change the probability of occurrence of another event. And then there's your dependent events, where the occurrence of one event affects the occurrence of another event. For the first scenario, the probability is for A and B, it simply equals to the multiplication of both the probabilities. And in second case, the probability for the occurrence of both the events is equals to first the probability of occurrence of first event times the probability of second event only after the first event has already occurred.